Yeah, in last video, we introduced you some concept like a decision boundary, decision functions, and give you one examples of decision function and the decision boundary. In this short video, I will give you some math reviews about you're gonna introduce you some math notations we're gonna use along the semester. Okay, so first we're gonna denote vector by the usually we use x to denote the vector, which has several components, like denotes the feature vectors. For example, the x1 could be age, x2 could be income. And a lot of cases, we have more than two features. Okay, and sometimes it's more convenient to using, so the vector, we mean the column vector. And a lot of cases, to save the space, we also use the row vectors. x5 with this transpose. This denotes a transpose. And we use the upper letter. With upper letter means the matrix, random variable, for example, we sometimes use the capital letter A to denote matrix, B denote matrix, random variable like x, y, we denote random variable. Like for example, x follows a normal distribution, so this quantity we denote x. Sometimes we also use a set to it denotes a set too. And the lowercase lower letter denotes the vector, like the one we just showed you here, the x, for example, x, z, to denote the vector of the feature space. We also use Greek letters too. For example, alpha, beta. So this denotes the scalar. And there are also some commonly used letters like n denotes the sample size, number of the sample points. Or sample size. D denotes number of features. For example, in our previous example, we have the D equals to 2, right? And we have the I, J, K denotes the indices. For example, we have the sample size n, so usually we denote x1, xn to be our this n is so we can use xi to be any of them. So instead using this long notation here, we can just say our sample is in a set xi, such that I is from 1 to n. So this means this means this. Okay, so in all cases we use I to denote the subindex, which means i's sample size. or you have the x equals to the feature space x1, x5, say xj could equals to, j could denote the number of the features. Also, we have some functions. So usually we use f. We use g denotes the functions. Okay. Once we have two vectors, the inner product. So here in today's class, we're gonna use a lot of inner product. So x inner product y equals to x1 times y1. Remember, x is a vector of D component, y is also a vector of D component. So this is inner product is just component wise, you multiply them together. YD, okay. Another notation can be used is, you can use this is just x transpose y. So this means this means this. And today we're gonna introduce our first classifier as a linear classifier. Where classifier decision function is equals to a weight dot product, inner product, with x plus some constant alpha. Okay, we're gonna come back to this. And what's the notation of this? The norm. So this is called norm. So usually it means the length of the vector x. So think about if you have the a vector x. Suppose this x is just 1, 1, 1. Okay. So what's the length here? What's the length of this vector? So if you have the x coordinates 1, y coordinates 1, so 1 square plus 1 square, and you take a square root, right? Square root of 2. So the norm of the x is nothing but your component wise, you square it, you take the sum, and you take a square root. So that's the norm of x. Okay. A lot of cases we use a unit standardized vector. So given x is not equals to the origin, okay, x divided by its length is a scalar. It's a unit vector. And the inner product has some special geometric meaning. Actually, if we have the vector x and the vector y, this is x, this is y, and suppose the angle between these two vectors is denoted by theta, then the relationship between the inner product is cosine. If you take calculus, this denotes the cosine of this theta gonna equals to x inner product y divided by the length of the x and the length of the y. Okay. So another way to think about this is you can think this is cosine theta is just the inner product of the standardized unit vector of x, inner product of the unit vector of y. Okay. So for example, if your remember the cosine theta function is if this is 2 pi, this is pi. The cosine function is denoted by, this is the cosine function, right? So in other words, the inner product, the x inner product is y is greater than 0. This tells us what? This tells us this theta will be is acute. Because if this cosine theta will be positive if it's below 90 degree, right? So, and if the inner product of two vector equals to 0, so this means theta equals to pi over 2. Okay, if x inner product is y is less than 0, this implies, so it means it's over 90 degree. So which means theta is obtuse. Okay. And in today's class, I think I will pause the video and I could keep talking next one.